How are anomalies in data analyzed in science? If you're curious about how scientists identify and analyze anomalies in data, you're about to uncover some fascinating methods. Let's break it down step by step. Anomalies in data are essentially points or patterns that don't fit the expected norm. To identify these, scientists use several approaches, each with its own strengths. Statistical methods. One of the simplest and most common methods is using statistical techniques. These assume that normal data follows a specific distribution, like the Gaussian or normal distribution. For example, the z-score method calculates how many standard deviations a data point is away from the mean. If a point is more than 2 or 3 standard deviations away, it's flagged as an anomaly. There's also the modified z-score, which is more robust to outliers and uses the median and median absolute deviation, M and D, instead of mean and standard deviation. Machine learning-based methods. Machine learning algorithms are another powerful tool. These can be unsupervised, supervised, or semi-supervised. Unsupervised methods like k-means clustering or autoencoders identify anomalies without labeled data. They work by finding data points that don't fit well into any cluster or don't reconstruct well using the autoencoder. Supervised methods, on the other hand, are trained on labeled data to distinguish between normal and anomalous patterns. Semi-supervised methods combine both, using labeled normal data and unlabeled data to train the model. Rule-based methods. Rule-based methods rely on explicit rules defined by domain experts or business requirements. If data points violate these rules, they are considered anomalies. For instance, in a financial system, a transaction exceeding a certain amount without a valid reason might be flagged as an anomaly. Density-based methods. These methods determine outliers based on how densely packed the data is. Algorithms like db-scan, density-based spatial clustering of applications with noise, and isolation forest work by identifying points that are far away from the densest areas of the data. Isolation forest, for example, uses decision trees to isolate outliers by randomly selecting features and creating decision trees that split the data until each instance is isolated. Time series methods. For data that changes over time series methods are used. These methods analyze patterns and trends in the data to identify anomalies that occur at specific times or under certain conditions. For example, a sudden spike in website traffic at an unusual hour could indicate an anomaly. Data visualization. Visualizing data is also a key technique. Tools like scatter plots, box plots, and heat maps help scientists see anomalies that might not be apparent through numerical analysis alone. Visual inspection can reveal patterns and outliers that would otherwise go unnoticed. Types of anomalies. Anomalies can be categorized into 3 main types: point anomalies, contextual anomalies, and collective anomalies. Point anomalies are isolated data points that deviate significantly from the surrounding data. Contextual anomalies deviate from expected behavior based on specific context, such as time or location. Collective anomalies are groups of data points that together exhibit abnormal patterns. By combining these methods, scientists can effectively identify and analyze anomalies in data, ensuring that their findings are accurate and reliable. Whether it's through statistical metrics, machine learning, or visualization, each approach plays a vital role in uncovering the unexpected in data.